Hi, my name is Andrew. I'm currently studying for the PCNSE. Um, when studying for the PCNSE, you'll see this Palo Alto Knowledge-based article referenced a lot, Packet Flow Sequence, also called Day in the Life of a Packet. It's a really great article that goes into depth about the packet flow through the Palo Alto. And I've read this a few times. When I read it myself, I found myself getting kind of bogged down into the details, which is great, it goes into the details, but I found myself losing sense of the bigger picture. So I wanted to make a video on kind of the higher level picture, constantly referencing the diagram to get a overall sense of how the packet flow works. And if you haven't read this article yet, I'd highly recommend reading this first. If you have two monitors, it's great to open up this image in a second monitor, have this on your first monitor, or you can get the high-res version right here. So read it once, and then I would say just come back and watch this video, and then read it again. And hopefully you'll have a much better understanding of what's going on. So to start, the article does mention that the ingress and egress stages handle network functions and packet forwarding decisions. So there's nothing too uniquely Palo Alto about the ingress and egress stages down here, so I don't want to spend too much time on them. There's not really too many surprises in the ingress stage. It's going to process the packet, look at layer 2, 3, 4 information. From this, it's going to be able to get the ingress interface and zone, of course. It's going to do, fragment reassembly if it needs to. If there's some kind of processing error, it's going to discard the packet, and they list some of the details of situations where that might happen. Protocol number 0, the TTL is 0, checksum errors, things like that. Nothing too unique about Palo Alto here yet. Then it's going to take a look at whether firewall inspection is applicable. And you might be wondering, well, in what cases would a packet not be eligible for firewall inspection? And in section 3, they have a table that lists that. The first thing I noticed was that for layer 3 interfaces, there doesn't seem to be any situations where the firewall would forward the packet without inspecting it. Seems like either it would inspect and forward, process it, if applicable here, or just drop it. Layer 2 is where you see a lot of the forwarding without inspecting, like for flooding broadcasts, things like that. And then finally in this stage, there's going to be IPsec SSL VPN tunnel decryption. So if it senses that it's a IPsec SSL VPN tunnel packet, it's going to go through decryption and go through the ingress process all over again. And now, what will the source interface be? The source interface will be the tunnel interface that is associated with that tunnel. So let's go down to really the meat of this article in this diagram, and that's in the Palo Alto firewall processing sections: fast path, slow path, app ID, and content inspection. Just a quick overview of what we're looking at here. Fast path is, you can just tell by looking at the diagram, is what it will take when there's already a session. So the way I think of that is if it's already seen the first packet, there's already a session set up, now it's going to go through fast path, it's not going to have to go through slow path anymore. And you'll see they very clearly labeled it slow path is also called session setup. So it's very clear that slow path is used specifically to set up the session. From then on out, packets that continue to match that session do not have to go through this slow path. They can just continue through fast path, app ID, content inspection. So let's go through slow path, and that's where this article starts. So first, what we need to do is we say, okay, the packet is subject to firewall inspection. It didn't skip all this, go to egress. It performs a flow lookup on the packet. So how does it do that? In PAN-OS implementation, it uses a 6-tuple key. And this is important. I'd really suggest drilling this if you're studying for the PCNSE like I am. So 6-tuple, there's source destination IP, source destination port from TCP UDP headers. Now for non-TCP UDP protocols, there's different fields used. don't need to get too much into the details there. Protocol is the IP protocol number from the IP header. So like TCP would be IP protocol number 6. Security zone. Now I believe if it was me, I'd like to edit this and call this ingress security zone because this is derived from the ingress interface at which the packet arrives. So kind of stepping to the side for a moment, why wouldn't you use the destination zone on the flow lookup? Why do you think Palo Alto uses only the ingress security zone and not the destination zone? And I believe the answer is because to determine the destination zone, you need to do a forwarding lookup, and that's not going to happen until the slow path is set up here. And then if there's a destination not involved, you're going to have to do a second forwarding lookup. So if there's no need, if flows can be uniquely identified between each other with only the source zone, I mean, why go through the process of determining the destination zone? So we've got the 6 tuple, once again, source IP, destination IP, source port, destination port, protocol number, source zone. Then this goes into details about the flows, how the client to server and server to client flows work, which I think is kind of self-explanatory. You know, the first packet is always going to be the client as source to the server as destination. Subsequent packets from the server to the client are going to be allowed if as long as the first client to server was allowed. So now let's go through session setup. We'll start with zone protection checks. What I noticed here that kind of bothered me was that there's no box here for zone protection check. It's kind of where is it? That's kind of where I got lost a little bit. And it would be nice if they included a box up here that says zone protection check to make it clear that that's going to be the first thing that's happening in slow path. So if you're familiar with zone protection check, you know that zone protection profiles are applied to zones and they apply to ingress traffic coming into that particular zone. So if it's going to check to see if a zone protection profile exists for that zone, and then it's going to subject the packet to evaluation based on that profile. So let's just take a look at zone protection here, just in case you're not too familiar with zone protection profiles. So zone protection is configured on the network tab. It's not like a policy and object. This is the way that a DOS protection profile is, if you're familiar with that. So if we just kind of look at adding a zone protection profile, you've got flood protection, where you can set rates for different types of traffic. You can protect against port scans, host sweeps. Packet-based inspection is where you see protection against things like spoofed IPs, fragmented traffic, TCP sends that contain data, things of that nature. Protocol detection, I believe it is typically applied to vWire and layer 2 interfaces where you can exclude particular protocols from entering into the zone. So once you have a zone protection profile, you would apply that to your security zone right here. You know, you would go into here and select the zone protection profile. And if you're not too familiar with zone protection profiles, I would recommend this video from the Palo Alto Live community. If you just search Palo Alto Zone Protection, you'll find it. And also, as well, the admin guide has a section that explains zone protection profile as well. And so once you read about zone protection profiles, you might see that the zone protection profile only applies to the first packet in a flow. And when you read that, you might think, okay, I'm going to have to remember that. The zone protection profile only applies to the first packet. Any subsequent packets don't have to be inspected by the zone protection profile. But really, it's not too much of a trivia thing, because if you look at the diagram and you understand that zone protection only happens during slow path, which is session setup, any subsequent packets in a flow don't go through slow path. So by definition, they don't go through zone protection checks. So next we have TCP state check. And again, this isn't something that's really well represented on the diagram, in my opinion. And to me, this is kind of related to zone protection checks because it looks at the zone protection profile, like the flood settings, and sees if, are you using sent cookies or, read, and it goes into detail to that. It's really good to read this I won't spend the time reading this, but I would recommend going through this because it definitely relates to zone protection profiles. Next is where we see our first box in the diagram, which is forwarding setup. So what's happening here is simply, in my opinion, is just getting the destination zone. And it does say that here, get egress interface / zone and VSys from layer 3 route, layer 2 lookup, etc. So one thing that I think is really good to understand, kind of test your understanding of interface modes, is let's, if you cover up this section right here, and you can kind of quiz yourself and just kind of think through, okay, for the interface mode of tap, what would the forwarding action be? So a tap interface is used when maybe you configure like a spam port on a switch, and you're really just using the Palo to kind of get a feel for what traffic it would allow, what it would detect, things like that. You're not the Palo is not in the line of the traffic, so it's not doing anything except for just giving you some visibility. It's the traffic is being mirrored over to the Palo Alto, so it's just going to drop the traffic. The firewall is just going to discard the packet. Oops. vWire. How does vWire work? You give two interfaces. You assign them as vWire and you associate them with a vWire object. And you'll hear vWire called as bump in the wire. The firewall is just placed between two devices. It's the most transparent way of introducing the firewall into an environment where you don't have to change routing and things like that. And so what would the forwarding action be? If it comes into one vWire interface, it's just going to go out the other vWire interface, right? It's just going to get forwarded through the peer interface. Next, for layer 2, this one's, I think, is a little bit easier. It's just going to do switching. It's just going to do a MAC lookup and forward out that destination MAC from the MAC table. And of course, if it's not present, the frame is going to be flooded to all interfaces in that associated VLAN broadcast domain, except for the ingress interface, just basic switching, right? Switching 101. For layer 3, it's just going to do a route lookup, right? It's layer 3 routing. Uses a route lookup table to determine the next hop and discards the packet if there is no match. So in this section is where we get that destination zone. Next, we're going to do a NAT policy lookup. And what's important to know about this is that it's not applying the NAT. It's just simply looking it up to determine, hey, do I need to apply NAT for this? Does this match a NAT policy? And why did it need to do forwarding setup before NAT policy lookup? Like, why couldn't do it first? Because what's really interesting about NAT policy lookup is take a look at this. So for destination NAT, the firewall is going to perform a second route lookup for the translated address to determine the egress interface zone. So if you understand, you might be familiar with the relationship between NAT policy and security policy. And you might know that security policy uses the post-destination NAT zone. So that's why this does that at that second lookup, right? It makes sense. It needs to now, it's like, oh, okay, I'm translating this untrust IP to something in my trust, a 10 dot IP or something. So now let me look up to see what zone that's in, because my security policy is going to be based on that zone. But why didn't it just do this beforehand? Like, why couldn't it do NAT policy before this so it didn't have to go through route lookups twice? I believe the reason is because the forwarding setup is you need to determine the destination zone, and you need that destination zone to do NAT policy lookup in the first place, right? Because NAT policy lookups reference source zone and destination zone. So that's why you just have to do this double route lookup in the case of destination NAT. Okay, so let's move on to user ID. That's another one that's not really pictured here. In my opinion, it would be nice if they included a box for that. The firewall is going to use the IP address of the packet and query the user ID mapping table to see if, hey, I've got this IP, does that match a particular user, because my rules might be based on users. And if that user information is not available at this point, it may do captive portal authentication later, which we'll see later. Next is DOS protection policy lookup. Again, not pictured here. When I was looking through this, I thought maybe the reason why it's not pictured here is because they ended up changing the order of these. Because if you look at the very top, there is this mention that DOS protection lookup is done prior to security policy lookup since 702 and 617. So I don't know, maybe that's the reason why it's not really pictured here, because it was kind of subject to move around between OS versions. But DOS protection policy lookup, if you're not familiar with it, it's kind of similar to zone protection. It offers the flood settings that are similar. Let's look at a DOS protection profile. So that's, you configure a profile as a security profile, then you apply it to a DOS protection policy rule. And you can only configure flood protection or resources protection, which is just the maximum amount of sessions. And then this profile gets attached to a policy, and the policy specifies the traffic that it's going to apply this to, like source zones, source IPs, destination zone, destination IPs. And usually, I think you'll apply this to protect like resources in your DMZ from floods and getting hammered with tons of sessions. So it's interesting to know that zone profile protection happens way before DOS protection policy lookup happens. And then finally, we get security policy lookup. Oh, and by the way, I should mention, if you're not familiar with DOS protection profiles, this is a good video to watch on that. And of course, reading the admin guide will give you a better understanding of DOS protection policy. So now we're at security policy lookup. And when I first saw this, I was pretty surprised. Like, wow, there's so many checks that happen before we even look at the security policy. I would have never really thought of that without reading through this article. And what's really important to know, in my opinion, is that at this stage, the firewall is going to use application any to perform the lookup and check for a rule match. And why is this? I believe it's because there's no use in running the app ID engine. Like, that's probably kind of expensive from a CPU standpoint, maybe. I'm sure there's a better way to explain that. But if the traffic is just going to end up being denied anyway, there's no reason for the firewall to go through the process of identifying the app if it's just going to drop it on the first packet, right? So what it does is it says, okay, I'm just going to pretend like the application doesn't matter. I'm going to check the port. And I've seen this referred to before as like a port check, because it's just taking the port and trying to find a rule that matches based on that port. So that if the port matches, it goes, okay, it looks like this might be allowed, so let's go through the process of identifying the app, doing content inspection, and everything else. And you might also have a question about how app ID relates to port checks. Like, let's say you migrated from a different firewall to Palo Alto, and as you're studying for the PCNSE, you're probably familiar with that process, and going from legacy port-based rules to app rules, and using the policy optimizer. And let's say you've gone through all of that, and now you're 100% using best practices, you've got all app ID rules. What would the service be on those? The service should be set to application default, right? So all those app IDs that you're using in your policy have an associated default port that they're permitted on. So the firewall knows this. So let's say you've got a policy rule that is allowing SSL specifically on application default. Well, the firewall knows that SSL is using 443 by default, so it's going to do a port check on port 443 for that particular rule. It's knowing that, hey, this might not be SSL, but let's just see if it's okay. It's 443, it's allowed. Let's go further. So to go further, now it's going to allocate a session, and it's going to create and install a session, and now we're going to go to FastPath. We're at FastPath. Now this section allocation, I don't think it's too important to go into the details. Basically, it's seeing if, hey, do I have room for a session, because the vsys might, it has a maximum amount of sessions, so it could hit that maximum, make sure everything's okay there. And now let's go through the firewall FastPath process, and here's where NAT is happening, right? So I think it's really good to understand that before in slow path, we're just looking up the policy during that evaluation, but here is where the NAT is actually taking place. And now we're going to go through security processing, and of course, we're going to have to decrypt packets if we're using SSL proxy. And we're basically going to go through app ID and content inspection stages, in 5 and 6. And here's where captive portal is happening. It's not really pictured on here, right? But remember before with user ID, which coincidentally also is not pictured here, if it couldn't determine user ID and it needs to get that user information, it may do captive portal. So that's where this will happen. But the packet is going to be redirected to the captive portal daemon. So now let's get into app ID. This is really important, right, to Palo Alto's implementation of their firewalls. And if you're familiar with app ID, without looking at this, what would you think would be the first step that would happen? Would it start inspecting the packet and classifying, based on signatures? Well, the first thing that will happen is a application override policy lookup. That's the first step, right? And that makes sense because if you're going to override app identification, you're going to do that first to determine if you need to override the whole process or not. So if you're not too familiar with application override, it's not too complex. It's just basically identifying traffic and then forcing it to be a particular application and overriding the whole inspection process. So you can identify by source zone IP, destination zone IP, and then you need to identify by a particular TCP or UDP protocol number. All of that was identification process, and then you're going to assign it to a particular application. So I believe typically you might create a custom application, and you won't set any signatures or anything on it, and you'll just call all of this traffic based on how many layers are you going deep with this. You're only going up to layer 4, right? Because you're only going up to layer 4 TCP UDP port numbers. And you're just going to call it, okay, that matches everything on that matches this particular application. If so, now you're going to do a security policy lookup based on that application that you just overrided it to. If there's no override policy match, then you're going to go into pattern-based identification and go through like the heuristics and everything that's kind of proprietary to Palo Alto to determine what application it is. And if it determines, oh, now this was SSL before, but oh, hey, and now this is actually Facebook. Now it's going to do security policy lookup based on that application again. Determine, okay, now SSL was allowed, but is Facebook allowed? Because now that's my app ID. So once we're allowed based on the application, we're going to do content inspection. And when I see content inspection, I kind of picture these security profiles here, like antivirus, anti-spyware, vulnerability, file blocking, wildfire analysis. Those are applied to security policies, right? And when you're learning about these, you might come across the fact that these are only applied to traffic that is allowed, right? So you might see like a practice question. If traffic is denied, will security profiles, will antivirus, will anti-spyware, will file blocking be applied to the traffic? And the answer is no. And you might think, okay, I'm going to have to remember that, right? But really don't have to remember it as a trivia question. It's just an understanding of how the flow works, because if the packet was denied for some reason, if it was denied on the security policy here, if it was denied even before setting up the session, then it never has the chance to get to content inspection, right? So by definition, any denied traffic doesn't have the opportunity to get to the content inspection stage. And that's a design choice of the firewall, right? Because then the firewall doesn't have to go through the processing labor of inspecting traffic that's just denied anyways. Okay, so back to content inspection. Let's the application might change from content inspection. So then we're going to go through this again and determine that there's a security policy for that new application, right? And of course, every time we're reevaluating the security policy, it may be discarded if that application is not allowed. And then we're going to take a look at, was there some detection result? Was there some file blocking result, some action that we need to take based on this? And if so, we're going to apply the security profile action. And of course, those are all set on individual profile definitions, right? This is where you can determine what your action is that you're taking. So after all this, if the packet is still allowed. Now we're going to re-encrypt it, if applicable, and we're just going to go into the egress stage, right? And the egress stage, again, like the ingress stage, is not too interesting to me. Nothing too unique to Palo Alto here. Just kind of basic network processing, right? Process the packet forwarding, do routings, do switching, do vwire forwarding, do QoS shaping, fragmentation. If it belongs to a tunnel, encrypt it, and then go through this process again and transmit the packet. So one thing I forgot to mention, I believe, is for app ID override. If you're interested in learning more about that, there's a video that's pretty new actually on the live community. I think this one was one I found I need to kind of speed up to kind of keep my attention, but it's nonetheless it's a good video to get more understanding of it. So let's go through the session setup one more time, because again, when you want to go back to study this and you just look at this, you kind of lose all of the zone protection, DOS protection, user ID, all of those lookups that are happening. You don't really see that just by glancing at this as a refresher. So let's go back up and go through again what is happening during session setup. Okay. So we've got a zone protection check. We're going to do TCP state check, and that's kind of related to zone protection, right? I'll kind of put that kind of underneath it in a way. Then we're going to do forwarding setup, which is basically just get destination zone. Then we're going to do NAT policy lookup. Remember, we're not applying NAT, just doing a lookup. And if there's a destination NAT, do forwarding again, forwarding lookup again. Next, we're going to do user ID, DOS protection check, policy lookup, and now we're at security policy. So again, I think it's important to understand that during session setup, all of these checks are happening before we get to security policy. And then finally, if allowed, allocate session and initiate fastpath. Go down fastpath, and at a high level, what's happening here? It's applying NAT, it's doing app ID, doing content inspection, right? So that's all I have for today. Again, if you haven't dived too deep into this article, I'd highly recommend going through all this again, because I hope that now you'll have a better high-level picture, and as you go through the details, you can kind of keep that picture in your mind and just kind of fill in with those details. So thanks for watching. I hope this was helpful.